Okay. So, there's a problem on joint probability distribution function. The joint probability distribution of two random variables x and y is given as follows. There are certain values. Before writing into the table, I shall tell you. Okay. You are being asked to find the marginal distributions of x and y and conditional probability distribution of x, provided y value is given to be 1. Okay, just see here, guys. X values, you can see they are ranging from 0 to 1 only. Okay. And then y values, if you see, they are ranging from 1 to -1 only. Okay. But then just to maintain that uniformity, I'll just be writing -1 because for y -1 value is there, for x -1 is not there. Similarly, for x 0 is there, but for y 0 is not there. Okay. So to maintain that uniformity in the joint distribution table, joint probability distribution table, I'll be using all the values that x and y both are taking. Okay. Like y is taking only -1, but I've written it for x as well. X is taking 0, I've written it for y as well. Or to maintain the uniformity, it is -1, 0 and 1 for x, -1, 0 and 1 for y. Now let's see how do we write the probabilities. Okay, is there any value for x is equal to -1? Is there any value for x is equal to -1 and y is equal to -1 in the values that are being given to me? No. So I'll be putting 0. Similarly, for x is equal to 0, x is towards this side, guys. Y is towards this side. For x is equal to 0 and y is equal to -1. Is there a value in the table? No. For x is equal to 0 and y is equal to 1, there is a value. For x is equal to 0 and y is equal to -1, there is no value. So I'll be putting 0 here. Now you see. Similarly, again, come towards my row. X is equal to 1 and y is equal to -1. Is there a value? Yes, there is a value. That is what? 1 by 3. So I'm writing here. This is the one. So I'm writing here, right? Next, similarly, I'll be checking the remaining rows row-wise or column-wise. Okay. Yeah. Row-wise, x is -1. Y is 0. Okay. X is -1 and y is equal to 0. Is there a value? No. Okay. Yeah. X is equal to 0 and y is equal to 0. Is there a value? No. Again. For x is equal to 1 and y is equal to 0. Is there a value? No. So the whole row is 0 only, guys. Okay. The whole row is 0. Third row. Second row is 0. Right. Now for x is equal to -1 and y is equal to 1. Is there a value? Again, no. For x is equal to -1 and y is equal to 1, there is no value. For x is equal to 0 and y is equal to 1, yes, there is a value. That is 1 by 3. So I'll be writing here 1 by 3. You can take x and y either ways, guys. It is not compulsory that x should be top and y should be bottom. Either ways you can take. There's no problem at all. Yeah. For x is equal to 1 and y is equal to 1. Is there a value? Yes, there's a value. That is 1 by 3. Now, what I need to do is to find the marginal distributions. I just need to add all the rows and all the columns, guys. That's it. It's as simple as that. Okay. Yeah. If I add the first row, the value would be 1 by 3. The second row, all zeros are there, so it would be 0. Third row would be what? 2 by 3, guys. Similarly, I'll add all the columns for the marginal distributions of y. So first column would give me a 0. Second column would give me a 1 by 3. Third column would give me a 2 by 3. Now, add the row sum, guys. What does it give me? And similarly, add the column sum. What does it give me? It gives me 3 by 3. Both of them give me 3 by 3, which is 1. Which again shows that sum of all the probabilities is 1. The third axiom or second of probability is satisfied completely. Okay. So, how I will write the marginal distributions of x and y? Just see here. Marginal distributions of marginal distribution of x. How will I write? Just see here, yeah. Just see here, guys. That is capital X is equal to small x, probability of capital X is equal to small x. This is the way how I will represent. By the way, guys, this is a standard example from Gupta and Kapoor, an examiner's favorite question as well. Okay. Numericals, numbers may change, but the pattern of questions would be the same for the exams. Okay. Because Gupta and Kapoor is a standard book, and then you find joint probability distribution only, marginal distribution, joint probability, conditional probability for two-dimensional variables, stochastic independence, all those you find only when one and only one Indian author book, that is S.C. Gupta and Kapoor. So every example in S.C. Gupta and Kapoor has to be practiced, because even for the gate questions will come from this only, nothing outside this book. Okay. Yeah. So marginal probability distribution of -1. If I see here this way, if I see here, it is 0. Marginal probability distribution of 0, it is 1/3. Marginal probability distribution of 1, it is 2/3. Okay, that is for X. Similarly, marginal distribution of Y. Y is equal to Y. Probability of capital Y is equal to Y. Okay. Similarly, -1, 0, and 1, you look like for minus Y is equal to -1. It is what? 1/3. Yeah, for Y is equal to 0, it is what? 0. For Y is equal to 1, it is what? 2/3. This is how you will represent in the exam. This is how you will write in the exam. Marginal distribution of X and marginal distribution of Y. Now coming to conditional probability, guys. It's even more simple because you have the table. Okay. Conditional probability distribution of X given Y. Given Y. Of course, Y is equal to 1 or something is being given in the problem. Yeah, Y is equal to 1 is being given in the problem. Okay. Given Y is equal to 1 as well, I can write here. How will I find it? Just see. Okay. Yeah. P of X is equal to X. For capital Y is equal to 1. This is equal to P of capital X is equal to X comma Y is equal to 1 by P of Y is equal to 1. Okay, guys? Yeah. Now we'll be inserting X is equal to -1, 0, and 1 and see, check the conditional probability. This is very simple. Once you know how to write it or once you know the definition, is very simple. Okay. For Y is equal to 1. You know what exactly it is. P of capital X is equal to -1, Y is equal to 1, and P of Y is equal to 1. Okay. See the values here. I'll just be writing. P of X is equal to -1. I'll just show one value. X is equal to -1. P of X is equal to -1 and Y is equal to 1. Okay, so what will that be? P of X is equal to -1 and Y is equal to P of X is equal to -1 and Y is equal to 1. Y is equal to 1 is this. So what I will be getting here is what I have is 0. See here, P of X is equal to -1 and Y is equal to 1. This value is what? 0. So 0 by something is 0 only. 0 by anything is 0 only. P of Y is equal to 1. This is equal to 0. Okay. Come to the next one. P of X is equal to 0. Y is equal to 1. Okay. Yeah. How I should write? If you know the notation, my job is done. Y is equal to 1. Okay. By P of Y is equal to 1. Just see here. P of X is equal to 0. P of X is equal to 0 and Y is equal to 1. It is 1/3. And what is P of Y is equal to 1? 2/3 is the value. Okay. Yeah. P of Y is equal to 1. P of Y is equal to 1. This whole probability or the marginal probability which I have written here, this one is 2/3. This is what? 1/3 by 2/3, which would be 1/2. Okay. Yes. Next, P of X is equal to 1, provided Y is equal to 1. How I should know how to write it. It's all about the notation, how I should write. Then I know what to look for in the table. That's it. Y is equal to 1. This is a standard example which is very, favorite one for the examiner. X is equal to 1 and y is equal to 1. Let me show in the table and then I'm done with the job. Yeah, x is equal to 1. This is x is equal to 1. Okay, and y is equal to 1. Okay, so x is equal to 1, y is equal to 1. It's what? What's that value? 1 by 3. Again, it is 2 by 3. The denominator is 1 by 3 by 2 by 3, which is nothing but 1 by 2. Okay. So if you are asked to find, I can again construct a table according to Gupta and Kapoor. I can just, for x is equal to x, I can write like this. P of x is equal to x, comma, y is equal to 1. All the conditional probabilities I can write here because I have calculated. According to Gupta and Kapoor, if you write like this is the standard way of notating and the examiner won't miss checking for your answers and you won't be losing marks. Okay, with this I'll end this video and I'll solve one more problem. Joint probability distribution in the next video.